So I want to give you guys an equation. Cosine of theta equals negative square root of 3 over 2. Does that look like that one homework problem I just did for you on your last homework? Does that look like similar to that problem? You have a trigonometric function of a variable. This variable is theta, but your problem was x. Trigonometric function of a variable equals a value. This is the exact same problem as that homework. Exact same problem. Exact same type of problem, I should say. So what would we do to solve this? In your focus lesson at the beginning of this unit, I explained what we could do to solve for this. If we need to solve for our variable, which is theta, if we need to solve for this, we need to undo cosine. Well, how do we undo cosine? We have to use the inverse. Well, the inverse of cosine is cosine inverse. Right? We didn't talk about this for the last homework problem. I just said, hey, guys, if they're asking you to find the angle and they give you the value, you can find the angle. Well, here, cosine inverse of cosine is just going to leave you with theta. So I show this because what I want you guys to understand is cosine inverse of an angle of a value, they're asking you what the angle is. They want to know what is the angle for cosine inverse of negative square root of 3 over 2. So we go ahead and take a look. We look at our unit circle. Cosine. Forget about the negatives for a second. When is the reference angle? Cosine is, when is cosine the square root of 3 over 2? When is adjacent over hypotenuse of a special right triangle going to be square root of 3 over 2? It's easiest to look at the special triangles when the hypotenuse is 1, because then all you got to do is look at the x-axis. So does anybody find a point there? Anybody find a point? Where? Green triangle, which is what degree? In radians, please. Pi over 6. Good. So we know there's a point. Pi over 6. Square root of 3 over 2, comma, 1/2. Correct? That's our angle. But that's not what the angle is. They want the angle for the negative one, right? OK. Now there are two other angles, though. Huh? OK. Now remember, it's always a rotational raise from here. Yes, the distance between those two would be 60, but that's not what we're looking for. We're always rotating from here. So if you flip it to down here, that's going to be square root of 3 over 2, comma, negative 1/2. Would everybody agree with me? If I flip it over the y-axis, wow, this point is negative square root of 3 over 2, comma, 1/2. And if I flipped it over the origin, it'd be negative square root of 3 over 2, comma, negative 1/2. Does everybody see all these values, right? And does everybody agree with me that all the values have a reference angle of pi over 6? Yes? OK. Now, two things we can do to clarify this. In your homework problem, they gave you a restriction, right? They said, I want your angle to be between these two angles, right? Well, we have restrictions as well. Our restriction is, first of all, these are the only two where cosine, where the x-coordinate is negative, correct? Those are the only two angles. So it has to be one of these two. Then, if you'll remember, what did we say the restriction on our cosine function has to be? It has to be between what? So do you guys agree how this angle no longer works? OK? So now, what is the angle then that produces this? Well, if this is pi over 6, that means that's pi over 6. So how far do you need to get to go over there? 5 pi over 6. OK? Or if you're thinking about this in degrees, if this is 30 degrees, that means that's 30 degrees. If all the way around is 180, 180 minus 30 degrees is 180 minus 30 degrees is 150. Do you guys see how that problem works? Yes? No? It's basically what we've been doing, but now you're finding the